Very long title on this one. Creating the equation of a quadratic, okay, from roots and a point. And we're not going to just do any equation. We'll get a specific equation, then we'll change it to standard form, just because that's commonly how sometimes they ask for things. They've given us roots and some point. So I got to talk about how we could build from here. First off, it's good to draw a sketch. Graphical representations are really helpful. Let's say there's a point at 2 and there's another point at 6. So we got a points at, here's our roots. Roots are x-intercepts, right? Yeah. So 2 and 6, which actually means this is at 2, 0 as a coordinate and 6, 0. Keep that in mind. They've actually given us the y values. Then another point at 3, 4. Is that 4? 1, 2, 3, 4. It's somewhere up here. There's a point at 3, 4. Okay. It's not quite the... what do we call it? Not quite the vertex. My parabola could go this way, but this point's inside those two. And if we were to draw it this way, it wouldn't connect to that point. So that means it actually doesn't open up. This parabola must be the opposite. It opens downwards. So it must go up, something like this, and then turn around and come back down. So it does something like that. Okay? This point is just somewhere on it. There's lots and lots of points. They've given us one. We have 2 roots. So we got to think about our 3 major forms. We have our standard form, so that's our ax squared plus bx plus c. So ax squared plus bx plus c. We have our factored form, which is our a times x minus r minus s. There's, lots of different people use different letters for those two. Something like that. I should write a subtraction sign there. And you have your vertex form, all the same thing. Ax minus h squared plus k. H and k. Okay. Notice the a value is the same all the way through. Okay? We always have that. What we're trying to figure out here is which of these versions we're going to use. When we look at it, they've given us the roots. The roots are actually really easy to plug in for one of these specific examples. Any ideas which one is the simplest version? Whether it's standard, factored, or vertex?
Would it be factored?
It would. This factored form is a form that's already got us into almost roots. Okay? So that's the best one to use. If they'd given us something like the vertex, it'd be best to start with this one and plug it. And if they gave us a y-intercept, so something over here, and like what it's stretched and compressed by, maybe this a value, then we could try to work with this. Okay? It still gets tricky. So we're going to take this form here, the factored form for what we're doing. And we have to remember that the r and the s represent the roots or the x values of the x-intercept. So one of them is 2. So we're going to plug that in. And the other one is 6. So we're going to plug that in. So that negative sign still stays there.
So the R and the S, what do they stand for?
They are technically our roots here. Now, it really actually is, this entire thing is equal to 0. Okay? So really what you could do to solve this is you say you have a root. Well, they've given it to us. There could be a coefficient here. I doubt in a question like this they're going to give you something like that. In fact, they don't have to, because if they give you a fractional value, you can just write r minus whatever this fraction is and still works out completely fine. Okay? So we'll just, for our intents and purposes, we'll say r and s are exactly the x-intercepts. So we plug them in. We have 2, that's one of them, and we have 6, that's the other one. Okay? They've given us a coordinate. Now, this is any coordinate along the line. So this is actually an x value and a y value. Now, if we look, we still don't have the a value. We don't have an equation yet because we don't have this constant. We don't know what it is. But we do have coordinates to help us because we have too many variables. F at x is kind of like y. We have x's here, so that's 1, 2, 3 different variables. We don't have enough information. But we can use this. There's an x value and there's a y value. Well, f at x stands for y, or it takes the place of it in our graph here. So what we can do is replace f at x with that 4. And our 3 is actually the x values. We'll replace both of those with that. So our f at x will become the number 4 is equal to a. And our x values are going to be those numbers 3. Minus 2 3 minus 6. Now I only have one variable, a. I'm going to isolate for a, and then I'll go right back to this version again and plug it back into the a, and I'll have my entire equation because I have my my roots or my x-intercepts. So I'm going to carry out some simplification. 4 is equal to a. This number becomes 1, and this number becomes negative 3. If I simplify that, I get negative 3a. I need to get a by itself, so I'm going to divide both sides by negative 3. Technically, this is a decimal, but I'm going to leave it as a fraction. It's going to be 4 over negative 3, okay? And like I said, I'm taking that and I'm plugging it back into the a value here to get my equation. So my equation would read f at x is equal to 4 over negative 3. Okay, did I do that right? Yeah. Bracket x minus 2, x minus 6. This is your equation in factored form. Now, I did say I'm going to put it into standard form, okay? And from factored form, there's all kinds of I could find the axis of symmetry, plug it in, and I can find a vertex and put it in vertex form. Or I can go to standard form and then complete the square. Like, there's all these different routes we can take to do this, okay? We're going to go back to standard form, which is just some distributive property. So I'm going to FOIL these brackets, 4 over negative 3. And we're going to get x squared, so the first x times x, and then x times 6. And then we get negative 2 times x, negative 2x, and we get negative 2 times 6 is positive 12. So I've just done distributive property in those brackets, which is like that FOIL we talked about. I kind of breezed through it, but you can always go back to that. These two are like terms, so I'll simplify them. X squared plus 4x plus 12. And then finally, I should, to be in standard form, I should distribute this 4 over 3. So we're left with, whoops, put it black here, 4 over 3x squared. This becomes 16 over 3x. And this one actually becomes, you can actually write this as just, is that right? I think you can write that as just 16. Yeah, that's it. I did the division quickly in my head there. Or you could have also wrote it as 48 over 3, and if you do that division, it goes like this. So it becomes 1. We have 1 remainder, 18. 3 goes into 18 6 times, so it becomes 16. Okay. So this is it. This is our standard form now. So just like we said, we took the roots and now we've put it into our standard form. So that's the process of creating an equation of a quadratic from roots and a point. So we got the factor form and then we put it into our standard form right after that.